Hi everyone, I'm Mario. Very happy to be here again at droidCon Berlin. Always exciting to be here. And yes, as we just said, I work at Amazon. My role is EU Technology Evangelist for the Amazon Digital Apps and Game Services, which means that most of the time when I have to add my job description into a form, I run out of characters. Also, Technology Evangelist has been officially voted in Italy as the second most stupid job title ever. But basically what it means is that I work with the community of developers out there. I'm an Android developer myself. I've been for quite a few years. I've been publishing my own apps even before joining Amazon. I've been a GDE for Android for a few years. And I've been working as a consultant, working in big companies as well, and now I'm at Amazon. But at the core, I'm still an Android developer, and I do development pretty much every day. And I'm very excited to be here to talk about one of the topics that I'm most passionate about, that I'm really focused on in the last few years, which is TV. So if you've been on the Android bandwagon from the early starts, you might remember how, the introduction of smartphones and then tablets really changed the way that users of these devices interact with apps. In around 2007, smartphones allow you to consume content in a new way, and then tablets around 2012 allow you to, have a bigger real estate and consume content in a different way. And now it's interesting to see how customers are start to consume content in another way. Which is on their TV. So smart TVs and streaming media players are becoming extremely popular. And the good news for developers like us, for Android developers, is that a lot of these devices, including Amazon Fire TV, are Android devices. I mean that we can start creating new applications and create new ways for users to interact with content. And when it comes to TV, it is no surprise if you ask me that the most consumed type of content, of course, is media. So it comes to media streaming through video and sometimes audio, but mainly is around movies and TV. And there is a new way, a new pattern that is now emerging and becoming more and more popular when it comes to controlling your environment. If you're in your living room, you might be talking to your Amazon Echo, for example. Or when it comes to TV, if you have an Amazon Fire TV, for example, you can use the voice remote to give commands to your TV. And it's a much more natural way to interact with this device, surprisingly, than using the remote. There are a lot of things that you can do using your remote. On Amazon Fire TV, you have Alexa on every Fire TV, meaning that if you're building a skill, you can also use that on Fire TV. You can ask it, what's the weather like to your TV, which is new. But the interesting bit is what you can do more than that, and how us as developers can leverage that. So I will go very quickly on the devices. So here in Germany, there are two Fire TVs available. One is the Fire TV 4K. It's a pretty powerful device. It's a quad-core CPU, 2 gigs of RAM, Wi-Fi, Bluetooth, and so plenty of horsepower to run pretty much even the most demanding applications. And then there is the Fire TV Stick. The Fire TV Stick is what's making mass market. Is still a pretty powerful device. It's still a quad-core CPU. Can still stream full HD content at 60 FPS. But the cool thing of the Fire TV is an extremely affordable device. On days like Black Friday or Prime Day, you can get one of these devices in the United States, for example, for around $35, which is crazy. So it means there are millions of these Fire TVs out there, and even here in Germany. But now there is a new thing that we introduced. So just a few months ago, we announced what are called the far-field controls for Fire TV. So if you have, let's say, for example, a Fire TV stick and an Echo, you can actually connect the two, and you can put your remote aside and just ask your Echo to have your Fire TV do something. Which means that we introduced basically far-field controls for Android applications. So what can you do with this? And in particular, when it comes to media streaming, what kind of actions can you perform? Here's a quick video that will demonstrate exactly what are we going to learn today. The actions that are controlled through the Android media sessions.
Incoming. Your signatures detected.
Alexa, fast forward 2 minutes.
Captain on the bridge.
Not too shabby, huh?
Alexa, rewind 30 seconds.
I'd say you're too confident for your own good, but I've seen your record.
As I have seen yours.
And your confidence is justified.
Alexa,
As is yours.
pause. Alexa, next episode.
So I should have given you spoiler alert for Star Trek. But anyway, what you've seen here is basically the usage of far-field controls on Fire TV. One interesting news, and I'm very happy that we had droidCon just a few days after this. Last Friday, we start shipping in the US the new Fire TV, which is called Fire TV Cube. And as you can see, Fire TV Cube is basically combining an Echo with a Fire TV. It means it's a Fire TV device with far field controls embedded in the device. Meaning it's an all-in-one that allows you to, again, put your remote aside and just talk to your TV and have TV execute your commands. But how do we do this? And is it complicated? Do you need to use additional SDKs to do this? Not really. So the good news for us is that if you're doing your job as a developer, as an Android developer, you are likely already building an application that will work out of the box with the Alexa Fire Field controls and with the voice commands that you can give on any Fire TV device. And that is because what we did is basically to connect specific Alexa speechlets directly to the Android media session controls. So let's just have a quick check. How many of you guys have already dealt with the Android media session before? Okay, so a couple hands. So this is good. So it means that we can deep dive on it. So if you would ask me, okay, Mario, what do I have to do differently if I want to add controls for Fire TV compared to a standard Android media session? I would answer that actually just one line of code that you have to add to your manifest. And this is just for Fire TV to recognize that your application is capable of voice commands. So this is just a permission that you have to add to your Android manifest. Everything else is just standard Android media session API. So something that you should be familiar with or can just learn through the official Android documentation. For the sake of this presentation, I will walk you through what is a basic implementation of the media session and how you can implement media session in a way that works nicely with the voice controls on Fire TV. So first of all, what are the commands that a user can give through voice controls? So there is a set of commands that user can give. There is play, pause, fast forward, rewind, next previews, and restart. In particular, for fast forward and rewind, there are an additional set of features which you cannot really do with a normal remote control, which is fast forward or rewind by a specific amount of seconds or minutes or even hours. You can say, Alexa, fast forward 30 seconds, or fast forward 10 minutes, fast forward an hour, same for rewind. And next and previews are also hardly found on a standard remote control, and those are to skip to the next or previous episode of a set of videos. So basically, we could say that these are the most common commands that if you're playing content, be it media, video content or audio content, you will likely use if you want to go hands-free on on a Fire TV, or if you just want to use the remote control with the voice button on Fire TV. So, okay, let's take a look at what does it mean from an architectural standpoint. So there are basically two main components when it comes to implementing media sessions correctly. There is your media player, which is actually the component that is going to perform the playback of the content. And there are a lot of different media players out there. There is the standard video view, which is available in Android, and this is what we're going to use today for the sake of this presentation. There are more complex players like ExoPlayer, for example. On the other side, there is the media session. So why is it important to have a media session along with the media player? So the media player only lives within your application, within the activities of your app. While the media session is basically the way that your application has to communicate to the underlying Android system and tell Android what is actually going on. That basically is telling the Android OS that your application is in control of the media playback. So the media session itself actually exposes a set of callbacks. These callbacks are basically abstract methods that directly map into all the most common actions that you would perform on a media player, which is basically the same commands that we just seen with the voice session, with the voice commands, like for example, play, pause, skip to next, or on seek to, which in this case, for example, is when you want to fast forward to a specific set of points. So how does it work when an Alexa speechlet comes in? So here's the situation. Let's say that, for example, you say, Alexa, pause. The Fire OS, which is the OS based on Android that runs on Fire TV, basically propagates the command directly to the action, to the callback exposed by the media session. In this case, it will map to the on-pause callback of the media session, and the on-pause will directly then implement the commands that control the media player itself, and in this case, we'll have the media player execute the pause method. And I'm not going to go through all of these callbacks for the sake of this architecture, because basically all of them work in the same way. All right, so there are a few steps that you have to take to correctly implement the media sessions in general. So the first step, of course, is to initialize your video player. Then you will need to initialize the media session for your application. You can have multiple media sessions, but for the sake of this presentation, we'll only have one media session to control the app. Then you will have to configure actions. So basically, you will have to define what actions the media session in your application can perform. You might want to decide that your application will only perform play and pause and not implement skip to next, for example. Even though my advice is to possibly implement as many as you can. Then finally, we'll need to manipulate to manage the media session during the activity lifecycle. We'll need to stop to release the media session in specific situations. And then the most important part, which is to set up the media session callbacks, and that's where the actual magic happens and you give commands down to the media player. So, all right, let's start with the first phase, which is, to be honest with you, I'm almost embarrassed to show this slide, which is just the basic on create where you set the video player and initialize your video player. It could be anything. For the sake of this presentation, we just used a standard video view. If you want, you can also, at the end of the session, you can also come and play with a test application that I built for this. You will see what the interface looks like. But if you're familiar with the standard Android video view, you know exactly what it looks like. So the first thing that we have to do is initialize the video player. The second thing that we have to do is to initialize what is called the media controller. So as you know, when you have media playback, you want to display on screen, in particular if you're doing fast forward or skipping to next or you're buffering, you want to display on screen the controls of the in a UI. For example, what is the current positioning of the playback, the play pause button, which button is being pressed, etc. All of this is done through a class called media controller that you need to initialize. And my suggestion is just to also call media controller hide, which will have the media controller disappear after a few seconds. So you show the hint to the player, to the viewer, and then it just fades out. Then you will need to attach your media controller to the video player and make sure that your video player is synchronized with the media controller. And then, of course, you will need to set the URI for your video. So in this case, I just hard-coded it here. You will likely probably fetch this from a database or fetch it from a cloud service, or if you're hard-coding it because you only have 3 videos, that's also fine. And the final part is to request focus for the media player. All right, that was pretty trivial. So let's go to the interesting part, which is the actual media session. So it's important that you initialize the media session when your video player is ready to go, when your video player is about to start the playback. So in this case, for the standard, video view, the video player actually exposes a callback which is unprepared, which gets called as soon as the video player is fully loaded. So in the unprepared method, that's where we're going to initialize our media session. So the media session just gets a context and a tag. That's because you might want to have multiple media sessions that you want to identify through different names. The second thing that we do, even though, to be honest, that's the last thing that we're going to see today, is to set the callbacks. It's basically saying, my media session is capable of doing these things, and this is how these things are done. And finally, you need to set the media session flags. And that's because, yes, we want to have the user play using their voice, but also it's important to keep in mind that the customer will also have a remote control in their hands, and that will do play pause possibly, or do transport controls using the remote itself. All right. The next things that we have to do is to add the actions to the media sessions. So basically, we just need to have the media session expose to the Android system what actions is capable of performing. And how do we do this? In order to do this, we need to use another class which is called playback state. In particular, in this case, we'll use playback state compat, and is best practice to use the compat version of this class, because it's it's the official Android one, is supported and works across a variety of different versions of Android. So it's very easy here. What we have to do is set all the actions that our media session is capable of executing. In this case, for example, is play, pause, fast forward, rewind, skip to next, and skip to previous. Maybe one that is missing here is restart, but there's also that action that you can do. So basically, this is very easy. It's just one line of code that says my media session is capable of doing these things. The next thing that you have to do is to set the state of the playback. And this is important because the playback state is what we're going to use to tell the underlying media session what is the current status of the playback. Is it playing? Is it stopping? Is it buffering? Is it rewinding? What's going on? In this case, the state requires a tag itself, which is the actual state. In this case, for example, we set to state playing because we'll immediately start playing the content. It requires the current position of the playback. And this is important in particular if you're going to do stop or play or rewind. So you need to have the standard position, and the default position for get current position is 0. And then there is one float here, and that number indicates the playback speed. So in this case, we put 1, which is standard playback speed. If you put 0.5, it will play at half the speed. If you put 10, it will be 10x. In this case, we just put 1. Then what you do, you set the playback state to the media session and set the media session to active. At that point, that media session is the only media session that is possible in the Android ecosystem. You're just saying, my application is the one that is in control of the media playback on this device. All right, then what we need to do is to manage the media session into the activity lifecycle. We'll need to play, pause, and stop the application the media session in specific activity, in specific events of our activity lifecycle. In the on-pause, for example, on-pause is an important method to implement correctly, in particular when it comes to Fire TV. And that's because when you say Alexa, or when you press the voice button on a Fire TV's voice remote, the system will automatically call on-pause. And that means that you need to manage your media session accordingly. In this case, what we need to do is set the playback state to pause, and we need to pause the video. And why is pausing the video important? Because when you say Alexa, as you've seen in the video before, an overlay appears on the screen, which is the Alexa screen overlay. And you don't really want the content to keep playing in the background. You just want to freeze it right where it is when the user has clicked the pause button. For example, when they said Alexa, you don't want to keep playing it in the background. So you pause the video. You deactivate the media session. In that moment, the media session should be paused. Also because on-pause could also be called because another activity comes in. So you want to deactivate your media session in that second. The other thing that you have to do is to then set the new playback state. One important thing here, every time you set the playback state, you also need to set the actions again. And why is that important? Because if you don't do that, you will be actually adding a new playback state which doesn't contain the actions. So basically, you are removing the actions from your application. From that point on, your app wouldn't be capable of listening for these actions. So it's important that you add the actions again. In this case, I just condensed them in a method called getActions that will just provide all the actions that we saw before. And then you just build the playback state and assign it to the media sessions like we've seen before. On stop is also very similar. You just set the playback state to stopped. You stop the playback, deactivate the media session, and again create a new playback state again. On resume is important as well. You remember when I said that as soon as you go into on pause, the playback should stop. So if you say, for example, if you say Alexa, you've pressed the button, and you don't do anything, you don't give a command, you just press the back button, or it just fades back to the activity, this will trigger on resume immediately, meaning that your video needs to start playing again. So in on resume, you set the activity to true, set the playback state to playing, set a new playback state, request the focus for the video player, and restart the playback. That's exactly what is happening here. And then on destroy is when, again, as you know, is when your application gets terminated. And the most important thing that you have to do here is to release the media session. If you don't release the media session, the system will need to automatically release it for you, but you don't have the certainty of when that is going to happen. Meaning that if another application is going to take over, the media session might not have been released correctly yet, and this could cause errors. And also, I'm saying this because at Amazon, we have a review process when it comes to evaluating the correct behavior of a Fire TV application. This is one of the most common mistakes, is not releasing the media session properly. And these actually, in most of the cases, have the review fail. So please take care about releasing the media session correctly in the on-destroy. All right, now we get to the interesting part, if you ask me, which is where you actually implement the media session callbacks. This is where you're actually connecting the commands that come down from the media session itself to the actual playback that happens in the video player. So, as I said before, the media session callbacks basically provides a set of methods that are not implemented. You will need to implement them depending on which actions your media session can perform. So in this case, these methods are on play, on pause, on seek to, on fast forward. Actually, there is a list of, I think it's like 10 or 15 methods that you can implement. And each one of those mimic a specific action that the media player can perform. In this case would be, for example, play, pause. Seek to is when you do fast forward to a specific position. On fast forward is when you just say to fast forward. So let's start looking at these methods. It's actually pretty easy to implement these methods. For example, on play, what you have to do is create a new playback state and says that the playback is playing, is state playing. What you do is similar to the on resume that we've seen before. You set the video to start the playback. You update the playback state. Again, it's the same lines of code that we've seen before, you just condense them in a update playback state method, as you can imagine. Just nothing more than just updating all the actions and all the status. So in this case, it receives a playback state, the current position, and the playback velocity. And then we also want to hide the media controller. Keep in mind, again, as I said before, these commands allows you to show the media controller and then to hide it after a few seconds. The next one is on pause. On pause, very similarly, you just need to pause the video playback, set the new playback state, and actually show the media controller. That is because you don't want your users to wonder what is going on as the content just frozen for some reason. You want to showcase through the media controller, through a UI component, that the content is being paused. Another trick that not everyone knows is that you can add a number as an argument to the show method, and that defines for how many seconds the media controller will be displayed on screen. And if you set 0, the media controller will be shown indefinitely. So that's pretty important to also give your users a clue of what's going on. On seek to is interesting. So, and here's, I think, is where you could see how powerful is the implementation for the Alexa, coming from the Alexa speechlets. So basically, when you see that on seek to receives a long as argument, which is basically the position, it's not really the position, it's more like the added milliseconds that you want the playback to skip to. The interesting bit is that when we were implementing the Alexa speechlets for Fire TV, we automatically resolve the pause argument. So for example, if you say, Alexa skip by 30 seconds, our implementation of the Alexa speechlets automatically convert 30 seconds into milliseconds. If you say 1 hour and 30 seconds, we auto-resolve that. So you don't have to do that. You just need to implement the seek-to method of your video player, just taking the current position and adding the argument. You don't really have to care about the argument because we automatically resolve that and convert it into milliseconds. Fast forward is actually a command that is used a lot, in particular in content playback, when you just say, Alexa, move forward, or say, okay, skip. In this case, you're not passing an argument. You're not saying for how much the content should skip forward. You can decide that. So I've seen applications in which the default seek-to value is 10 seconds, like in this case, it's 10, then 4,000 because it's millisecond. Or you could do skip by 30 seconds, skip by 10 minutes. It's up to you to decide what is the right type of automatic fast forward when the customer says, Alexa, fast forward. Skip to next. Again, here I didn't add any specific implementation of this, and mostly because this will really depend on your application. This really depends on how you fetch the next video and how you implement it. But basically, the core concept here is that you need to create a new playback state that is skip to next, and then implement the fetching the new content, set the new URI, and start the playback again. So again, it's pretty trivial implementation, but it's dependent on your implementation of the list of videos, how you're fetching the next video. Is it based on preferences? Is it based on machine learning? Entirely up to how you implemented your application. And that's pretty much it. So we've seen how easy it is to add the media sessions. The interesting bit, guys, is that everything that I've shown here is not just applicable to the voice controls. Pretty much, this is just a standard implementation of media sessions in general. If you're creating a media application for smartphones, you will go exactly through the same implementation steps again. Maybe there are some actions that you will not implement. There are also some custom actions that you can add. So the media session API allows you also to add additional custom actions, entirely up to you. But recapping it, the main points are initialize the video player, initialize your media session, configure the actions, so basically expose the media what actions the media session in your app can do, manage the media sessions in the activity lifecycle, and set up the media sessions callbacks in order to connect the media sessions to the implementation of the actions in the media player. Before I let you go, I want to also, tell you one thing. So everything we've seen here is if you have to implement the media sessions itself. But what if I tell you that if you have content, if you have videos or music, there is already a way for you to create high-quality media streaming applications in an easy way. So basically, a way for you to build applications for TV in just a few minutes. And this tool is a tool that Amazon created, and it's called Fire App Builder, which is a template for creating high-quality Android applications for TV. So the Fire App Builder is basically a plug-and-play template for audio and video apps, and it really allows you to create an app in less than an hour. I've seen developers implementing a full-blown application in around 15 minutes, connecting to a set of video content. So first of all, Fab, the Fire App Builder, is is full-featured. Has a lot of plugins, you will see in a second, that allows you to do complex implementations. What if you want to add in-app purchase to your application? What if you want to add analytics? Or what if you want to add social login and things like that? We have plugins for all these features. It handles JSON feeds or even XML feeds. So basically, if you have content, let's say on a cloud service, let's say you have a set of videos in a S3 bucket, and you have a bunch of metadata in a DynamoDB or somewhere where you can expose it as a JSON, then the Fire App Builder is capable of taking your JSON, interpret your JSON, and populate the interface automatically. It supports the Amazon Fire TV family. I should also mention that it works on Android TV as well, given its Marshmallow or app. And why am I talking about this? It's because the Fire App Builder is already fully configured to work with voice controls. So if you use Fire App Builder, you don't have to do anything of what I said in the last half hour, because it's already done for you. So this is what the interface looks like if you would play with Fire App Builder, except for the artifacts, which is just recording issue. So everything you see on screen is being dynamically generated, starting from just a JSON of content. And is capable of playback, is capable of providing rich interfaces, automatically populating the text, and has its own implementation of ExoPlayer as well. He has modules for in-app purchasing, subscriptions, social login, analytics, advertisement, media player. And the beauty of this is that all these modules are plug and play, meaning that if you have your own implementation of media player, you can build your own plugin for the Fire App Builder and swap it in and swap it out. And for each one of those, we have an abstraction layer that we provide in a way that you can use the ones that we provide, like, for example, the Facebook login or these login with Amazon. But you can also add your own custom login system. Same thing for ads or analytics. Everything is pre-configured for you. So very, very quickly, how does it work? You configure your feed. We don't really care about the tags in your feed. That's because what you do, you set up what is called a recipe. The recipe is basically is just a JSON file where you are mapping the tags of your feed to the tags that Fire App Builder is capable of understanding. It's basically connecting your content to the content that Fire App Builder can display on screen. You can then customize UI and modular components. We try to put an abstraction layer on top of classic XML, so we just have configuration files that you can easily customize to change the size of the widgets, to change the colors, to change the appearance of the images, and so on. And finally, you just launch the application. So I don't really have time to cover all of Fire App Builder. I hope that has sparked your interest. It's an open source project. It's on GitHub. Please go and clone it and start playing with it. I'm sure that you're going to like it. And we also have full documentation on our Fire App Builder doc page on the developer portal. And also, if you're interested in building high-quality media streaming applications, I wrote with my colleague Peter Heinrich, I wrote an ebook around building media streaming applications, which is available for free. You can just download it from this link, and it explains all the frameworks that we have and all the different features that we covered. And with this, I have finished. So here's my Twitter link, so please add me on Twitter. If you like this presentation, here's the link to the slides. You can just download it, and everything I said today is available there. Here's my email. Please use it wisely. Please don't send spam. Just send GDPR compliant stuff, please. And also, at our booth, which is just outside here, we're doing a prize raffle. But if you fill out this form or the form that we have at the booth, you can win an Amazon Fire TV. So can start playing with what I said today and start creating the next generation of Fire TV applications that leverage voice. If you want to play with Fire TV, please also come at the booth. You can play with the voice controls yourself. And don't forget to add your email, otherwise I cannot reach back to you and I cannot send you the Fire TV. So hope you like this presentation. Thank you very much for your feedback, and I'll be around, and I'm just the obstacle between you and food, so just go for it, guys. Thank you very much.